In this video, we are going to learn how to write the rate law of a chemical reaction from a rate versus concentration data table. The rate law of a chemical reaction shows how the rate of a chemical reaction is affected by the concentrations of the reactants. If I want to write the rate law for the reaction A plus 2B gives C plus 3D, the rate law is going to be as follows. Rate is equal to K times concentration of A to the power X times concentration of B to the power Y. K, it's called the rate constant and it depends on temperature. X, it's called the order of the reaction with respect to A, and Y, it's called the order of the reaction with respect to B. X, it shows how the reaction rate is affected by the concentration of A. If X is equal to 0, it means that the rate of the chemical reaction is not affected by the change in the concentration of A. Y shows how the rate of this chemical reaction is affected by the change in the concentration of B. If I want to find the order of the reaction, I have to add the exponents. N, it's equal to X plus Y. To determine the order of a chemical reaction, we cannot find it from the equation. There is no relation between the order and the coefficients of the balanced chemical equation. So to determine the rate order of a chemical reaction, we need to use an experiment like in the following exercise. We have a table that shows 4 experiments. We are changing the concentrations of A and B and we are getting different rates. I want to find the order with respect to A, I want to find the order with respect to B, and I want to find K. Also, I want to find one of the rates. Here we have to agree on something, that the rate law is equal to K times concentration of A to the power X, concentration of B to the power Y. If I want to find the order with respect to A, it means that I need to calculate X. To calculate X, we need to use 2 rates where we have the same concentration of B. Why? Because when we divide 2 rates and we have the same concentration of B, we can cancel it. Let me show you how. Imagine I want to find X. I am going to choose rate 2 and divide it by rate 1, which is equal to K concentration of A to the power X 2 and concentration of B to the power Y 2. The concentration 2 it means. And divided by K times the concentration of A to the power X 1 and the concentration of B to the power Y 1. So I'm going to replace the concentrations by their values from the table. Rate 2 over rate 1 is equal to 5.12 times 10 to the power negative 4 divided by 2.56 times 10 to the power negative 4. It's equal to K. Replace the concentrations by their values. Concentration of A2, it's equal to 0.4 to the power X. And B2, it's equal to 0.2 to the power Y. Then in the denominator we put K, and the concentration of A1 it's 0.2 to the power X, and the concentration of B1 it's equal to 0.2 to the power Y. So we can cancel the 0.2 power Y in numerator and denominator, and also we can cancel the K. So we're going to end up with 2, it's equal to 2 power X, which means that X is equal to 1. So the order of the reaction with respect to A, it's equal to 1. The second part, I need to find the order of the chemical reaction with respect to B, which means that I need to calculate Y. Here we have to choose 2 rates and divide them, and these 2 rates, they should have something in common, which is the concentration of A. I'm going to take rate 3 and divide it by rate 1. Rate 3 divided by rate 1, it's equal to K concentration of A to the power X, 3, times concentration of B to the power Y, which is 3, divided by K concentration of A to the power X, which is 1, and multiplied by concentration of B to the power Y, which is 1. Replace the rates and the concentrations by their values. You are going to get 4.096 times 10 to the power negative 3 divided by 2.56 times 10 to the power negative 4. It's equal to K, replace the concentrations by their values, 0.2 to the power X multiplied by 0.8 to the power Y, and the denominator we put k times 0.2 to the power x multiplied by 0.2 to the power y. 0.2 power x and 0.2 power x can be cancelled, and k should be cancelled with k. We're going to end up with 16. It's equal to 4 power y, which means that y it's equal to 2. Here, the order of the chemical reaction with respect to B is 2. The order of the chemical reaction with respect to A is 1. If I want to find the order of the reaction, it's going to be equal to 1 plus 2, it's equal to 3. If I want to find K, I need to replace the concentrations in one of the rate laws. I'm going to use the first one. Rate, it's equal to K times concentration of A to the power 1 times concentration of B to the power 2. I replace the concentrations by their values. Rate, it's equal to 2.56 times 10 to the power negative 4. It's equal to K. 0.2 multiplied by 0.2 squared. I'm going to do the math and find that K it's equal to 0.032. For the last part, I have to calculate the rate of experiment 4. Now I have K and I have the concentrations with their powers. I simply replace them by the formula. Rate it's equal to K concentration of A to the power 1 times concentration of B to the power 2. I put 0.032 times 0.4 times 0.4 squared. The answer is going to be 2.048 times 10 to the power negative 3 molar dot second. So this is how we find the order of a chemical reaction. We compare two rates with the same concentration of one of the reactants to be cancelled, and K will be cancelled. Then you are going to find the power for that reactant easily. And then you choose two different rates with another reactant with the same concentration for you to find the power for the second reactant. This is how to find the order of a chemical reaction from a rate versus concentration data table. If you find my videos are useful, subscribe to the channel and hit the bell icon to get notified and watch the new videos. Don't forget to share this video with your friends and write me a comment. Thank you.